Today I'll try to, usually in the last webinars I've been completing a schematic from start to end. I don't pretend to finish today. The diagram I will draw probably will last for 2 or 3 webinars. I took some ideas from a book of hydraulics I purchased recently, so I will try to represent a test bench for servo valves. So today I will concentrate on the power unit, and during coming webinars we'll try to finish and complete. And during this exercise, I'll try also to bring you information, ideas how to use efficiently HydroCAD. So we always start with blank drawing, and in my case, I use a standard template I have customized. So when you start from this ribbon, this menu, you can select. Usually, I start with the hydrometric. I built my own Hydro Start. It's a metric template which I'm using today for my diagram. HydroCAD is divided in several ribbon menus. On top, we can see them. Let me highlight them. So we have the circuit, system, and so on. To place a title block, I will go to the System tab and insert the title block. And let me take an A2. It will not be that big. My power unit is made of 2 pumps. One will be a vane pump. So now I'm going to look for a symbol of a vane pump. In the Library Explorer that we have on the left, we have a search engine for symbols. So we can type in what we are looking for. In my case, it's a pump. And inside my library, I will go for a fixed pump, single. And I'll take this one with a pass-through shaft, because I will need to connect later another pump. So this is my first pump. As you can see, when you find a symbol in the Library Explorer, you just double-click and insert the symbol in the drawing. And on the right, you will see all the relevant attributes linked to that symbol. So my pump will show all the relevant attributes. In my case, this pump will have a displacement of about 120 centimeter cubic by revolution. And I will connect an electric motor. On the left. I will leave room for a coupling set. So I will now look for a coupling set. And I'll take my symbol for a coupling set. The bell housing is under motor pump adapter. So by looking for adapter, I will just go into the reservoir and power unit components, motor pump adapter, and I will take my bell housing symbol. Let me clean up a bit our drawing. So that's my first part. My electric motor will have about 100 kilowatt of power, and I will put it somewhere here. You can move item IDs wherever you want in the drawing. Change balloon styles just by double clicking on the top right here. You can select a different balloon styles, but usually when you find your standard, I recommend you keep your standards. If you want to change the balloon styles for your drawing, please remember you can do directly in the options. Hydro options are directly available in the circuit menu by clicking Hydro options, this button, or there is a shortcut. You can type YO and enter, and this will open the Hydro options. And if you go to the balloon, you can see that you can customize the balloon style for your components in the diagram. Now my circuit is made of a variable displacement pump with a controller that is limiting the maximum pressure. So although we have several symbols in my library, so let me first save my diagram and put into the webinars, and that will be, let me create a new folder and call the September webinar. and that will be my power unit. So although we have plenty of symbols, now I'll show you how to build a symbol for a variable displacement point with limiting the maximum pressure of the system. So in the new HydroCAD 2021, we have a new mode to build symbol. So on the circuit, you can click down symbol and build symbol. When you build symbol, HydroCAD will enter in a specific build symbol mode, which is handy, and it's very easy to build the new symbols. I'm looking for a pump variable, pressure compensated, a single pump, and I'll take my symbol, this one, as a starting point, but my symbol is slightly different from this. But when you are in build symbol mode, any symbol that you place will be automatically exploded so that you can really easily modify it. On the top, we can specify the component type we are building. So this is a pump variable single. And now let's start building my logic. So I will remove a bit of entities. I put my tank line down here. I'll make some room, so selecting, and this is base AutoCAD, so I will go a bit faster. To delete items, you just select and delete. So usually variable displacement pump have the spring that keep the maximum displacement, like in this case. I need to connect one side of the swash plate directly to the tank line, like I'm doing now. While I need to control the signal that goes to change the displacement with a pressure compensator. On the top here, as you can see, I have some quick shortcut to run commands, AutoCAD commands that I need frequently. I'm running now this command, which is very powerful, which is called Stretch. It's AutoCAD Stretch, and it allows me to select a portion of the diagram and made a change in the shape. So now, as a maximum pressure limiter, I need a relief valve, so I can search for a symbol, and I just take a standard relief valve symbol. I don't need really ports here, and I want to flip this symbol, so I will use AutoCAD commands, mirror, and I want to delete the source entities. And this is okay. Let me move my symbol here, and I can use the match property command to copy geometries. And on the right, we can see ISO building blocks that allows us to find elements to build quickly our symbol. So I need to connect my relief valve to the tank line. And now let's complete the other part. So here I need a pressure compensator. So let me go through logic elements and find something that is similar to what I need. Later I will modify it. So this will be a compensator. Let me take this one, then I will modify it. So I put it somewhere here. I don't need ports, so I need a three-way pressure compensator. So let me clean up a bit. And the spring is on the opposite side. Right click, move from here to here. So the compensator will take the pressure from the P line of the pump. So I will just use a dashed fluid line, go in here, and I will take my, I want not only to represent the two sides, two positions of the compensator, I want also to represent the third position, the intermediate one. So I use again the stretch command, and I will just make a change here. and I can just copy, right click, copy entities, and this is going to be here. Now the main position, well, let me do again just to reduce the space. And also I move down, right click, move, and take it down. Now the position is a dashed fluid line from here, and I'm going to connect here, and then just doing the connection. So by default, this must go to the tank line. So I will look into the spools for a good symbol. This one is okay, and I explode because I need only 3-way pressure compensator. The center position is something like this, and explode. I always don't need the fourth port, while the fourth position is different. This one must be flipped upside down. So yes. This line is going to the tank. So we do a connection to the tank. So by default, tank line and tank line on the swash plate, the spring is winning and keeps the maximum pressure. Now we need to make the pilot on our pressure compensator. So basically, we need an additional dashed line here that goes to the tank. And here we need to have an orifice. When you place a symbol from the building blocks, you can directly rotate left by following the instructions in the command line. And also this one is going to be connected here. The maximum pressure, now it's not really a good position, so let me again do a modification to the position. Let me move it to the right a bit. I will move everything to the left to gain more space. This is fine. The pressure line is going from the pressure compensator here. Then I need to connect my pressure line here, and I take another node. So as you see, when you build a symbol, I don't use a HydroCAD connection line. We'll see later in action in the diagram, but when building symbols, I recommend you don't use a Hydra connection line. You just use lines and arcs, and you find in the symbol editor all the commands that you need to make that. Let me stretch a bit more, because I need to connect this one with the relief valve, another node, and I need an additional orifice. My symbol is almost complete. The only thing is that I want an additional external port in order to be able, if I want, to unload the pump with an external signal. So I will just create a line going to the outside of the pump, and I will insert the symbol port called PS. And we'll see later that we connect this port to other items for our diagram. Our symbol is almost complete. The only thing I want is I want to be able to display the displacement. So by using add display format, let me clean up. So add display format. I want to take the displacement and add next to the pump symbol. So I want to position it here. While I see that the pressure settings for the relief valve is not available in the pump, it is possible to add additional properties to a component type. We will not look today at this feature for a Hydro Library Manager. Now, as a workaround, I want to add in the insert menu, I want to define an attribute for that block. So this is going to be a block. So I want to define an attribute. This is the command. Define attribute. And the attribute, I don't want to lock the position. The attribute will be setting. And I want to place it next to the spring. In order to keep standard layers, I go to symbol editor, match properties, displacement with settings so that they are okay with the same styles. Now my symbol is ready, and I can just save changes. And place my symbol in the drawing. So this is my newly created symbol. I close the building blocks, and let me also clean up the drawing. I open the property manager by clicking edit, and now if you see, I select the symbol, I can take the displacement. This one will be a 100 centimeter cubic by revolution, maximum displacement. And if you double click on this symbol, now I will see an attribute called the settings where I can put the settings. So it will be 350 bar. So this is a workaround where a new symbol has not that pressure setting attribute, because this symbol has a pump, has no pressure setting. So I'm adding a custom attribute with AutoCAD functionalities. Now let's start building the logic for our diagram. So this pump, the vane pump, will feed the variable displacement pump. So I will take a suction line going down here. So the pump is taking oil from the reservoir, which I'll represent later, and the pressure line will go as inlet for our variable displacement pump. This is not usual. This pump will not work at high pressure, so I will take a relief valve and screwing cartridge, pressure control, relief valve, and I take a standard relief valve, which I position here and rotate to the left and move it here. And this is going to be connected here. And this valve, now this is a relief valve, so the pressure setting is available as an attribute, is here, and this valve is set at 50 bar. So it's a very low pressure. Also, since this is a test bench that will feed a servo valve, I want to control the filtration. So I will put a pressure filter on the outline of this pump. So now I'm going to look for a filter and strainer. Single filter, and let me take this one. And I want directly to rotate to the right and position on top of a connection line. So when you place a symbol on top of a line, automatically the two line segments will be broken into two. And this is my filter. And later I will, well, let me put some lines. So this one is going up, and this one, I want to put a pressure gauge and a pressure switch on this connection line. I put on top because I want to have all the measuring device on top of my diagram. So let me close here, and I go to gauge. I take a pressure gauge and put it here, and also a pressure switch. And this is, I'm going to rotate left and place on top of the connection line. You can move the item ID. Now, in this case, the balloon is not following. If this is not happening, there is a quick way to restore the balloon just by selecting and changing the balloon style, or we have a fast command to do that in one go directly in the system tab. It is called balloon. I may use it later. So now this tank line is going directly to the reservoir. So it's like a drain line, but we want to keep it separate. My drain line is going to the tank as well. And my tank line is going down here. Well, actually, I will get a return line. So I will first make a big vertical line and connect my relief valve. As a test bench, usually you want to keep the temperature of the oil under control. So I will put a heat exchanger, a cooler, in my connection lines. So I want to flip horizontally, flip vertically. Sorry, this is not the way. Let me flip it. And we can move the symbol directly on top of the connection line. If I place a symbol on top of the connection line, it will be broken. Now I want to represent a reservoir. I will use just AutoCAD commands. I create some lines. This will be my big reservoir. If you want, you can specify layers like all the other items. So to change layers, which means change color styles for AutoCAD entities, you can select the entities in the drafting menu. You can go and say isolene uni. Now I want to build a symbol on the fly. Unlike what I did earlier by doing a really custom symbol, this is very easy. I don't need much interaction. To make a symbol on the fly in your diagram, you go to the System tab and use the Convert to Hydra command. So Convert to Hydra command will work on a selection of entities. First, you specify the component type. In my case, it's a reservoir. And I select the entities, enter for confirmation and the insertion point, which is this one. Convert will build our symbol on the fly. Now let's keep building our diagram. After our pump, we have a check valve. Now instead of searching for symbols, I want to search for components. So I go to more search options and I need maybe a Bosch Rexroth valve. Bosch Rexroth. I need a check valve, skewing cartridge, because I will put everything in a manifold rated at least 160 liter per minute, 160 liter per minute, and search. So this search is done in Fluid Power Tools database. And now, as you see, I am finding some check valve. So let me take this one and place it in the drawing. And I want to connect my pressure with a check valve. I am planning to make a manifold and where I will put all the components. So the manifold will be somewhere here. So I will move my relief valve and my filter on top because I want really to make a big manifold with all the components and connect the manifold directly with the pumps and with the heat exchanger and going back to the tank. So with this idea, I'm going to modify a bit the position of the symbols. Always this HyDraw Stretch command is very handy because you can select and make a change in the position of a symbol very quickly. The item ID can go up. A new change in the logic for connection lines in HydroCAD 2021 makes very easy this situation. You just move the symbol up and automatically the lines are following. In the past, previous versions were leaving the connection dot where they were. So this is an improvement in this newer version of HydroCAD. After the check valve, we are going to the other part of the test bench. There will be another filter, high pressure filter. So I will just copy this symbol and place it here. I want to rotate to the right and move it. And I make my connection. And then there is my outline going, P-line going to another part of my test bench. I need an accumulator. The accumulator would be needed to reduce flow rate change. So I will take a bladder accumulator and take it here. I will need also to measure. So I will copy these two symbols because I need to measure the pressure. And I need a pressure gauge and also a pressure switch. In this case, by mistake, I used a solid line. So if you need to change, select the line and make it pilot control, as well as here, control line. To be able to control in our test bench the pressure in our pump. We want to control in two ways. One manually, so with another valve, copy selection, and I have a proportional valve, relief valve proportional. Let's take a surface mounted valve and search it. I'm finding this one, it's okay, PMVP4. If you want, you can view at the catalog, right click, view datasheet. And this is opening the datasheet for the proportional valve. But I'm going to use it. Double click and place it in the drawing. I want to rotate it to the right. And both tank line to the reservoir. The pressure will come from the PS. So in this case, we are sure, and so we will have in our test bench a way to control the pressure with a proportional valve and also with a manually operated relief valve, which now we put at, let's say, 250 bar in our system. But this will be possible to set directly in our test bench. An additional valve we want is to avoid peak pressure in the outlet line. So we are going to look for a symbol of a screw-in cartridge valve, a pressure control valve, a relief valve with this one should be fine. We rotate it to the right, position it somewhere here. We connect our valve. And we connect the back pressure of the spring directly to here, and we go to tank. Maybe not high as the full pump, but peak pressure, so we keep it as a separate line. Our diagram is almost complete. I want to extend a bit the tank line. Let me make some more room because I want to create the envelope. So I will move everything up again. So these items, I put the filter up. I'll move my valve up. Also this one will go up. And as well. And now I use the AutoCAD commands to move these entities up. So all these elements belong to my manifold. So I'm going to create an envelope. And the envelope is crossing my connection lines. So whenever the envelope is crossing connection line, it is creating external ports. So let's start naming this external port. This is our T1, and our flow rate is 150 liters per minute, which we want to size. So we need a SA flange. And although HydroCAD is recommending 1 inch, I will take a 1.5 inch code 61 flange. And I will copy this size with the opposite size. Okay, this will be my T2. This pump, this port will be called the P1 and is SA flange 1 inch 1x4 code 62. And while this one, P2, could be slightly less, 1 inch code 62. This is the port that will go directly to the other pump, and we keep it 1 inch code 62, and we call it P3. We have a small pilot line, so let's call it PS, and we take it BSP port 3x8. The anti-shock valve will be let's call it T4, and it will be a BSP 3x4, while we can keep 3x8 as a tank line for the small relief valve. And this is the T3. And we do again the connections. On top we have a test point, so this will be P2, TP2, BSP 1x4, MP2, BSP 1x4, and we can always copy the same size to all the other ports. I do a bit quick here. This is TU. This will be MU. And this one will be usage, which will be not a BSP 1x4, but it is a SA flange 1 inch code 62. And this one will be a BSP port 1 inch. And that's the accumulator. Now we want to extract a bit of information from our diagram. We have a lot of external ports in our symbol, and we want to collect a list of external ports. By going to the System tab, we can click Ports command, and we can select the manifold, enter, and next, and we get a list of all the external ports that we have defined in our diagram. We put it here. My diagram will go on in a different page. So for now, I will create some lines. And I will put some jumping reference. So this one will be tank, and we go to a second sheet. And this one will be pressure, and we go to a second sheet. We are not going to do it today, but next time we'll do the second sheet of this diagram. Now I want to make a part list, although I didn't specify all the components for my system, but in any case, you can have a part list and then you can fill in all the information for the part list. Before doing that, I will renumber items. So I will just go to the System tab, Item, and select just the power unit and start numbering from 1. So now HydroCAD is numbering from left to right all the components in the selection. I select all the manifold items, select all the manifold from 100. So now I have all the manifold items with starting with 100. So my bill of material will be very easy to read. All the power unit items and all the manifold items. I forgot to put some sensors in the reservoir, and I'll do it quickly. So let's put some temperature switch. I need for sure a thermometer. I need a fluid level indicator. All these are ISO symbols that you find in the standard library. And of course, this is available in the reservoir and power unit component. I want air breather and filling cap. So now I do again the same numbering only for the power unit. So I do again, item, select, enter, starting from 1. So now I'm able to make my part list for the system. So the part list for the entire system, enter. I have a dialog asking me what is the style of the part list that you want. So I want the Hydro default, and I want to include components and accessories. Although in my diagram I have no accessories, I include everything here. Next, I have a preview of my part list. And wherever you find empty spaces, you can fill in the information. So like in this case, the manifold is made by Vest. The model code is manifold webinar 123 with part number. When you update the information that you write, this information will go to the corresponding symbol in the drawing. The part list can be exported to Excel, or you can place it in the drawing. And now I want to move my part list. Select. To move a part list, you can just select the top left corner and move it. Or you select, right click, press move, start point and end point. So as you prefer, you find your preferred way. I want to make some room here, so always the Autocad Stretch command, which is very handy because we can make some change in the shape. Balloon for the envelope, we put it somewhere on the top left. That's the envelope. We also can reduce a bit the space inside the manifold for better readability using the same AutoCAD commands. Stretch. If you struggle with the ortho on, press F8. So then it will be only horizontal or vertical. F8 again will remove the ortho mode. The advantage of using a customized template is that now plotting this diagram is very, very easy because I selected an A2 page. So we go to my plot A2. It's already framed properly. So I will just go plot and make my PDF. I will go to my September webinar. And now this is the plotted item.